Good afternoon. Good afternoon, everyone. Hope you're having a great Wednesday here on the 12th of November, 2025. I am back to present my Teleconnections discussion for this week. All right, so let's first start off like I usually do here with a look at the Northern Hemisphere 500 millibar height anomalies. So it's important to take a look here in the Northern Hemisphere to kind of see what's going on with the upper level troughs, the upper level ridges, the position of those troughs and ridges. What are the wavelengths of those troughs and ridges? Are they longer wavelengths or shorter wavelengths? That all really has some major impacts on the overall storm track, as well as areas, that could potentially be drier or wetter than normal overall. All right, so let's start here, and we'll start it here in the upper left-hand corner. You see my red dot here above the graphic on the left. Wherever you see the greens and the blues and the purples, that indicates upper level troughs, and that's associated with unsettled weather conditions and colder temperatures. Wherever you see the orange colors or these lighter white or brown color, that indicates upper level ridges, and those ridges are associated with dry and very warm weather. So let's kick it off here in the upper left-hand portion of this graphic here. This is from the European Ensemble Prediction System. Current outlook of where the troughs and ridges are at 500 millibars or 18,000 feet above the surface. So we see a lot of greens and blues across northern and central Russia right now, and that's in association with we have multiple closed upper level lows. We have multiple troughs across that northern and central Russia area. We also have a pretty significant closed upper level low and trough extending to the south there from the southern portion of the Kamchatka Peninsula. An upper level ridge is positioned beneath the troughing over northern and central Russia. To the south there, we have upper level ridging across eastern China, right on into the Sea of Japan. A closed upper level low and a significant trough is positioned generally across the eastern. Oh, let me see here now. Not the eastern. This is the Kamchatka Peninsula. Excuse me. I'm moving on to the next one here. Okay, I'm getting ahead of myself. So we do have a anomalously above normal heights there over the Arctic area for today. You see the lighter browns and oranges, a strong upper level high north of Alaska across the Arctic region. Just some crazy higher than normal heights up to that location of the world, north of Alaska. We also see we have an upper level trough generally across the eastern North Pacific Ocean with a downstream upper level ridge generally positioned over the U.S. West Coast for today. We see a deeper upper level trough and closed low there across any ranging from the Midwest down over to New England. Southward, the trough axis extends into the mid-Atlantic. We see a downstream upper level ridge, and it's a strong one in the southern and central Greenland associated with a negative North Atlantic oscillation. Look at this ridge axis extending from the North Atlantic right on up into southern and central Greenland today. And we have a deep closed upper level low positioned to the west of Europe with a trough axis over the eastern North Atlantic. And then we have an upper level ridge from the western Mediterranean Sea extending northward into France. And finally, we have a weak upper level low to the southeast of the Baltic region. So if you look at the overall pattern here in the Northern Hemisphere today, a couple really eye-popping features that stand out here. Very strong upper level ridging into the central North Pacific Ocean up into the Aleutian Islands, right? We have anomalously strong upper level ridging and above normal heights across the Arctic area, north of Alaska and north of North America in general. Another anomalously high height center in the North Atlantic up towards Greenland, association with a negative NAO. We got a couple of really deep closed upper level troughs. We got a deep trough off of New England of the United States. Another very strong deep upper level low and trough to the west of Europe. Those two really stand out with the purple coloring here. We look at the Map-Julian oscillation MJO phases and areas of enhanced convection. The MJO ranges from phases 1 through 8, and you can kind of see where the enhanced rising air motion, the vertical air motion, and the convection would occur with the various MJO phases. MJO phase 1 is associated with convection or rising air motion in the tropical Indian Ocean there, right around Madagascar. MJO phases 2 and 3, rising air motion and convection into the Indian Ocean. MJO phases 4 and 5, You have rising air motion convection over the maritime continent, Australia. And right now we are positioned in MJO phase 6, where we have enhanced rising vertical air motion and convection across the tropical western Pacific. And there's potential for the MJO to move into phase 7 here over time. Now I'm going to show you what that looks like. The temperature composites are on the left for the MJO. So we're looking at temp composites for October, November, December. And the orange colors and yellows indicate above normal temperatures, the blue colors below normal temperatures. So you'll notice phases 1 through phase 8, right? Because that's where we're focused here, phases 1 through 8. So you notice that these MJO phases, they vary based on the number. So right now we are in MJO phase 6, which generally equates to more milder conditions across much of the United States. We do have a little bit of below normal temperatures from New England down to the mid-Atlantic coastline with MJO phase 6. If we move to MJO phase 7, we have warming across the Florida area, the southeastern U.S., up towards the mid-Atlantic. We got colder temperatures now across the northern plains to the Midwest in MJO phase 7. So what do we got going on right now here with the modeling for the MJO forecast? Now this is the Jeff's V12 model on the right from today, 12 November, forecast out to 26 November. The dark black line indicates where the MJO has been. It's like a running history of it. This black line represents where it was in October. Started out in the null phase in early October, worked its way out into phase 1, phase 2, phase 3, 4, 5, and started working into phase basically out of phase 5 towards phase 6 at the end of October. By early November, we're in phase 6. And that's where we're at currently. You see the red line, the blue line, the purple line here, the forecast for the Jeff's V12, showing the MJO kind of getting stuck there in phase 6. We look at the CFS V2 extended bias corrected on the left, this model, CFS V2, showing the red line, kind of like where we're heading. Showing the MJO basically being in phase 6 all the way through the 16th of November, and then coming down towards by late November, the last week of November, going to the null phase. And then the purple line shows the MJO coming out into phase 7, week phase 7, the 10 and 11 of December time period. We look at the middle diagram. This is the European MJO forecast from today, 12 November, through the 26th of November. Again, follow the red line, the blue line, the purple line. That's your forecast. Whenever you see the numbers along these lines, it indicates the day of the month. So right now, the 12th of November, rather, we're right here in MJO phase 6, and we work our way in MJO phase 7 according to the European model by the 16th. Then we kind of are straddling the null phase into phase 7. Over here on the right-hand side is the Bureau of Meteorology model. This is the BOM model from the Australian Bureau of Meteorology, showing the MJO. This is going out through 8 December. Okay, now it's a couple days old now, but generally it's showing that we're working our way towards phase 7 on this model, and then work our way around into the null phase, come back, loop around back into 6 and 7 again by the 8th of December. So as you can see, you see where I labeled milder temperatures generally occur for the eastern U.S. in the MJO phases 6 and 7. And that's associated with rising air motion and convection in the western Pacific. We look at the ENSO update here. Let's first examine the sea surface temperature anomalies across the northern hemisphere waters. We have, first of all, I want to mention we have a daily Southern Oscillation Index, SOI. Now, the Southern Oscillation Index, it measures the pressure difference between Tahiti and Darwin, Australia. So if we have a SOI value of a positive 7 or greater, that generally indicates La Nina conditions. If we have a Southern Oscillation Index value of minus 7 or lower, so basically more negative, that means that we have a El Nino. So folks, we've got a big drop in the daily Southern Oscillation Index, SOI. It's currently at minus 7.13 today. Now, this has dropped from last week's value. When I did my video last week, my Teleconnections discussion, we had a positive 26.97 SOI value. So what a drop we've seen over the last week with this value. Now, currently, orange colors, yellow colors indicate above normal water temperatures. Blue is below normal water temperatures. So let's examine the water temperature anomalies. Let's first look here at the North Pacific Ocean, since that's where the weather comes from, really. I mean, we're in the westerly wind belt. So, okay, so we got warmer than normal water across the northwestern Pacific. I like that north central Pacific area to the northwest Pacific there around Japan. Cooler than normal water is currently in place across the tropical eastern and central Pacific Ocean with a weak La Nina, and then also the far northwestern Pacific Ocean around Kamchatka Peninsula. And we see blue there in the Gulf of Alaska, below normal water temperatures there. On the Atlantic side, you'll notice how warm the water temperatures are across the Atlantic. A lot of orange coloring, right? Orange across the North Atlantic. That basically equates to more of a positive phase of the Atlantic multi-decadal oscillation, AMO. Whenever the waters are warmer, generally in the North Atlantic, especially off of Greenland, that generally tends to promote upper level ridging. And we've been seeing an awful lot of upper level ridging lately into Greenland in association with the negative NAO. We look at the overall boxes for ENSO intensity classifications. How do we classify El Nino or La Nina? NOAA, the Climate Prediction Center, is looking at the water temperature anomalies here in this rectangular combination of the peach color, the light red color, and this blue box. This rectangular box is a Nino 3.4 region. So depending on whether the temperatures are above or below normal helps NOAA to determine, are we in an El Nino or a La Nina? You see the other regions are here as well. Nino 1+2 box is just off the west coast of South America, Nino 3. Then you got the Nino 4, well to the west, right along the international date line, 180-degree west longitude, and even further west to 160 east longitude. So here are the different classifications based on the water temperature anomalies. A weak El Nino or La Nina would range from 0.5 to 0.9 degrees Celsius below normal water temperatures in this Nino 3.4 region. Moderate El Nino or La Nina would range from 1 to 1.4 degrees Celsius water temperature anomalies below normal or above normal, respectively, and so on. Now, this is the latitude and longitude coordinates for the Nino 3.4 region. Now let's take a look at these various Nino boxes here, 1+2, 3, 3.4, and 4. And let's see what the water temperatures are looking like in those areas. So we'll start with Nino 1+2, which is right off the immediate coast of South America. We see we have a value right now. The Nino 1+2 index from CDAS is minus 1.08 degrees Celsius. Okay, now let's move west to Nino 3. We're going to look at the Nino 3 area now. Water temperature, the latest trend, definitely see some cooling. We see this blue line really starting to dip down, right? So we have a value, CDAS Nino 3 index value of minus 1.20 degrees Celsius. And by the way, this Nino 3 area happens to have the coldest water temperatures right now out of all these areas. We look at Nino 3.4, that area, and we have a CDAS value of minus 1.17 degrees Celsius. And you can kind of see this blue line to see generally how those water temperatures have changed over the past week. I will say they have cooled from last week when I did a video here on the Nino 3.4 region. And then over here on the far right, bottom right, we're showing the water temperature anomalies, that Nino 4 index. We're in the Nino 4 box. We're out well to the west here, 180 degrees west longitude towards 160 degrees east longitude. And we see our warmest area. Our water temperature anomaly is minus 0.89 degrees Celsius in Nino 4. But you did see quite a drop-off here in early November. Pretty significant cooling there of the waters out in Nino 4. But things have kind of leveled off now. So our coldest water temperature anomalies are currently located in Nino 3. Okay. And our warmest sea surface temperature anomalies are back into Nino 4, further to the west. So coolest is here in Nino 3. The warmest temperature anomalies in the water are out here in Nino 4. Now let's look at the teleconnections, and let's look at the Arctic Oscillation, AO. And this thing has been persistently negative for quite some time now. And when you have a negative AO, you see it on the left here, what happens with your overall upper air patterns, where your storms track, with these red L's represent your storm track. You have your H's, which represent higher pressure. So with a negative AO, we typically see higher pressure over Greenland and then across the North Atlantic. We get a strong North Central Atlantic ridge, a Greenland block type pattern frequently develops or persists. And the jet stream varies greatly north to south across this area. You get more cold moving into south central Canada with a negative AO, into the Midwest specifically, and also to the East Coast. We recently just saw this past weekend for the upper Midwest and Midwest, and then all the way down here to the Mid-Atlantic. The last couple days have been pretty cold. High of 45 degrees yesterday on Veterans Day, November 11th. That's saying something. Also with a negative AO, you tend to get more of the East Pacific Ridge, which is more stronger and more persistent. Now, we haven't necessarily seen that yet on the Pacific side. So let's examine some things. By the way, this is a positive AL here on the right. Positive AO is usually associated with a stronger polar vortex, which keeps all the coldest Arctic air locked up over the Arctic area itself. And you get more of a milder pattern across the lower 48 from California right on through the southeastern U.S. You get more of a flatter jet stream look, more west to east. Coldest air remaining up over Canada to the north, mildest air over the United States, fast-moving low-pressure systems across the northern tier of the U.S. with a positive AO. Now let's look here. European EPS AO 50 per term member forecast out through 27 November, showing a negative AO right on through, all the way through the 20th of November. So what are we at? We're on the 12th today. So that's 8 more days of a negative AO according to this model. And then it becomes neutral from 21 to 23 November. And then it drops back negative again at the end of November. We look at the NOAA JEFS V12 AO 30 per term member forecast, negative AO, going all the way out through the 20th of November. And then now there's a difference here between EPS. See the EPS? It only goes mainly neutral there from 21 to 23 November, while the JEFS V12 wants to make the AO slightly positive from 21 to 23 November. No matter what, both models are in agreement. Both the ensembles are for the AO to turn negative again the last week of November. The North Atlantic Oscillation forecast, NAO forecast, this is, what we got going on right now. This picture on the left describes it perfectly. We have a negative NAO. We just recently had a deep upper level trough dig into the eastern U.S. We had record lows go all the way down to Florida and the Gulf Coast. Very cold air moved all the way basically from Canada down into the eastern and U.S. as a whole. And we have this strong upper level ridging across Greenland, blocking high aloft, milder air. It's redirecting the storm track. So we have colder air, typically with a negative NAO, that also troughing and colder air digs into northern Europe as well with this situation. Over on the right-hand side, you see we have a positive NAO example. When you have a positive NAO, the jet stream is much stronger, comes roaring in off the Pacific, and it mainly remains up over the northern U.S., the polar front jet stream. And what happens with that is you get fast-moving systems kind of coming across the northern U.S. with a positive NAO. Notice also now across Greenland with a positive NAO, that upper level ridge, that upper high is gone. It's been replaced now by a stronger Aleutian low. You have a greater pressure difference between the Azores high to the south and that Aleutian low. A very strong North Atlantic jet stream from west to east. Let's look here now at the modeling. European EPS NAO 50 per term member forecast. Follow this solid green line. That is the average of all 50 forecast members of this ensemble system. Look at this. Negative, 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 negative. You see the negative values here on the far, the y-axis here. The green line remains in negative territory right on through the 27th of November. The JEFS V12 NAO 30 per term member forecast shows a negative NAO through about the 21st of November, and this is pretty sharply negative on the 17th. You see it go up towards neutral line, the zero line here in the middle of the diagram. So transitions then to slightly positive from 22 to 25 November, then goes back towards neutral at the end of the month. So, overall, the trends with the NAO per both the EPS and the JEFS, we're showing generally a movement closer to the neutral line. The JEFS also shows the NAO going slightly positive from 22 to 24 November, whereas the EPS is not buying that at all. Looking at the Pacific North American PNA forecast, this is very important. We're going to shift our focus now to the Pacific side of things. Now, during a positive PNA, which we recently just had, you get very strong upper level heights across western Canada, along the western U.S., get above average temperatures in the western U.S. up into western Canada underneath the ridging. And with a positive PNA, you get deep troughing and colder than normal temperatures, more storminess into the eastern U.S. With a negative PNA on the right, we see troughing and colder than normal temperatures into western Canada down to the western U.S., very stormy across California, into the Pacific Northwest, Washington State, and Oregon, as well as Intermountain West locations. And you see orange colors with the negative PNA on this right-hand graphic. That basically indicates above average temperatures, above normal heights. Okay, so let's look at the modeling. European EPS PNA 50 per term member forecast showing a slightly negative PNA. Follow this green line here through 15 November. And then we go neutral from 16 to 18 November with the PNA, according to this model. And then we drop back negative again from the 19th to the 27th of November. The NOAA JEFS V12 PNA 30 per term member forecast out to the 28th of November shows a slightly negative PNA similar to EPS through 15 November. Then we turn slightly positive from 16 to 18 November with the PNA, and then we transition back to negative from 19 to 28 November. Looking at the Eastern Pacific Oscillation EPO forecast, a negative EPO on the left. We got a very strong upper level ridge across the northeastern Pacific. In some cases with a negative EPO, this ridge builds further up towards Alaska and covers much of the Bering Sea and even ridges north of Alaska with very strongly negative EPO cases. So we have upper level ridging across the eastern portions of the North Pacific. And then we have lower heights and lower pressure to the south of the upper level ridge, generally to the southeast. You get troughing southeast of the Hawaiian Islands. Notice what happens when you get this huge ridge to build up across the northeastern Pacific into Alaska. You get more of a cross-polar flow, more direct flow of air from Siberia, right on into Canada, down into the United States. If we look at the positive EPO on the right, we keep all the coldest air contained up over the Arctic area. We now have a stronger low pressure system there into the Northeast Pacific and stronger, higher than normal heights there to the south across the Hawaiian Islands and just to the west of the Hawaiian Islands. We do see milder air. Look at this. Milder air with a positive EPO from coast to coast, west coast to east coast of the United States, a flatter, more zonal west to east jet stream. Here is the forecast, European EPS, EPO 50 per term member forecast through 27 November, showing a slightly negative EPO through the 13th of November, turning positive 14 to 16 November, then neutral conditions from 17 to 20 November, then positive again from 21 to 23 November, before the EPO really starts crashing more sharply negative that last week of November. NOAA JEFS V12 EPO 30 per term member forecast out through the 28th of November, showing a slightly negative EPO through tomorrow, 13 November, then slightly positive from 14 to 16 November, slightly negative again. Look at this. This is an interesting little drop off. The EPS is not showing that drop off to negative as sharply as the JEFS V12. Look at this dip here in the green line in a negative territory from 17th to the 20th of November. Look at that. And then you go more neutral from 21, 22 November, and then we turn more sharply negative again for the EPO from 23 November to 28 November. Now, both of these models are showing this pretty significant drop-off to the negative side of the EPO, which that means that would mean we'd have a building upper-level ridge there into the northeastern Pacific, Gulf of Alaska perhaps, up into Alaska. We look at the latest stratospheric polar vortex update here. Currently, today, here in the upper left, we see a mainly symmetrical or circular shape to these white solid height lines, right? So when these white solid height lines, geopotential height lines, are more circular in nature, that means that our stratospheric polar vortex is stronger. Blue colors on these charts, by the way, indicate colder stratospheric temperatures. Yellow colors indicate warmer stratospheric temperatures, and you can clearly see that here with the legend here with the temperatures. All right, so what we have going on today currently, pretty symmetrical shape to some of these geopotential height lines around the vortex. And then here's the forecast for 16 November in the upper right. This is now showing this yellow area, some warming temperatures in the stratosphere, starting to push their way a little bit closer to the North Pole area. And what that's doing is it's starting to stretch the stratospheric polar vortex by the 16th of November. You're starting to see this shift. The stratospheric polar vortex shifts off the North Pole, and it's now working its way towards northern Europe. And then over here, the bottom center here, we show the stratospheric polar vortex forecast for 20 November. The yellow coloring indicates those warming stratospheric temperatures in the same general location. And then you have this displacement of the polar vortex and the stretching out of the vortex as well over here on the European side of the globe. So bottom line here, and there's been a lot of chatter in social media about a sudden stratospheric warming perhaps in late November. These effects after these stratospheric warmings are, it takes time for the stratospheric impacts to come down to the troposphere where we live. But just interesting, this polar vortex does not look like it's staying over the pole. And it looks like there's some weakening of it, is what I'm getting at. We look at the EPS, 500 millibar height anomalies here. This is today, 12 November, in the upper left. We have that deep upper level trough, closed low there, just off the coast of Maine into the northwestern Atlantic. We see upper level ridging across the western U.S., and we have upper level troughing over the eastern North Pacific Ocean. We do have some upper level heights building into central Aleutian Islands and into the southern Bering Sea, just west of Alaska. A couple other features up here in the higher latitudes today on the 12th of November. We see well above normal heights over the Arctic area again, north of North America. We see well above normal heights into Greenland, across the North Atlantic with anomalous ridging going on, association with the negative NAO. We see a deep closed upper level low across the northeastern Atlantic waters. Over on the right-hand side, upper right, we're showing the forecast for 16 November 2025. Upper level ridging starts poking its way toward the northeast into the southern Bering Sea. We see a deep closed upper level trough moving into southern California by the 16th of November. That would be Sunday. Upper level ridging is weak from Texas up through Idaho. And then we see troughing generally from the Manitoba province of Canada into Ontario, extending into the northern Great Lakes states. We also see above normal heights across southern Greenland, ridge axis extending, oriented more east to west into the Baffin Bay. And a closed upper level low will be located in the vicinity of the southeast Canadian Maritimes, with troughing extending off of that to the southeast across the northwestern Atlantic Ocean. Bottom left, this is the 500 millibar height anomaly forecast for the 18th of November, showing upper level ridging working its way into western Canada. We see an upper level trough now firmly in place across the western U.S. from Oregon, Washington State down through California, Nevada. We have above normal heights across Mississippi, Alabama, Georgia, northward through Illinois, Indiana, Michigan, Wisconsin, up into south central portions. That would be the Manitoba province of Canada. Well above normal heights continue across southern Greenland to the Baffin Bay, west of Greenland. This is just anomalously high heights for this time of year. Strong upper level ridging up into Greenland across the North Atlantic. That continues. And we see a closed upper level low and general troughing there off the New England coastline. The bottom right shows the forecast 500 millibar height anomalies for the 21st November 2025, showing upper level ridging anomalously above normal heights moving into portions of the northeastern Pacific. We see green coloring into the Bering Sea. That is associated with some troughing there. We see another trough in the green and blue coloring across the southwestern U.S., Nevada, into parts of western Utah, into southern California. A 588 decameter upper level high will be positioned over Cuba. We see upper level ridging, slight upper level ridging into the mid-Atlantic by the 21st of November. And we still see well above normal upper level heights there over Baffin Bay, west of Greenland, into parts of Canada. And then a closed upper level low and troughing generally extending across the northwestern Atlantic waters. So my final thoughts based on everything we discussed in today's teleconnections discussion. The MGO is currently in phase 6. Then it potentially moves into the null phase and phase 7 by about the 26th of November. Now, some of the modeling, I've looked at the European, I've looked at the CFS, specifically those two, European and CFS models, are showing movement of the MGO into phase 8 by about the 10th of December. Now, phase 8, what would that do? What would that do? Let's take a look at the temperature composites. Let's go back. MJO phase 8 would be a much colder scenario from the upper Midwest to the mid-Atlantic to New England. Okay, so we could see a transition to colder than normal temperatures by early December if we get the contributions from the MJO moving into phase 8. Now, in the meantime, it's in phase 6, all right? And there's a good chance it could move into phase 7 through the 26th of November. What does that mean? That means phase 6 and 7 favor milder temperatures across the eastern U.S. Now, there is a weak La Nina in place, but I will caution you, this weak La Nina, is, with the atmospheric response being the way it is, with the Southern Oscillation Index, we've seen this big drop from last week to this week, from positive 26.97 to a negative 7.13 daily SOI, Southern Oscillation Index. We do see below average sea surface temperatures there in Nino 3.4 region at minus 1.17 degrees Celsius, and that is down from minus 0.95 C last week. That's according to the latest CDAS data. Sea surface temperature anomalies across the northern hemisphere. We have warmer than normal water across the northwestern, and I would argue and even shift that a little further to the east and call that north central Pacific Ocean. We have cooler than normal water temperatures across the central equatorial tropical Pacific with the weak La Nina. Also cooler than normal water across the far northwestern Pacific around Kamchatka, and then cooler than normal water across the Gulf of Alaska. Models are indicating a negative AO phase through the 20th of November. We could see a potential shift, however, to more of a neutral and then a negative AO phase again by late November. But it could occasionally shift to neutral conditions. A negative phase of the AO favors colder than average temps across the eastern U.S. Neutral phase would favor near average temps in a more zonal west to east jet stream with weaker, faster moving high and low pressure systems. And then a positive phase of the AO favors above average temperatures across the eastern U.S. Models are indicating a negative NAO, North Atlantic Oscillation phase, to the 21st of November, then potentially neutral after that, after the 21st of November. A negative phase of the NAO favors colder than average temps across the eastern U.S. with troughing. Blocking ridge occurs over Greenland, there across the northern Atlantic. And neutral phase favors near average temps across the eastern U.S. and a lack of blocking. And then a positive phase of the NAO favors above average temps across the eastern U.S. Models are also indicating a negative to occasionally neutral PNA, Pacific North American pattern through the 28th of November. Now, if the PNA goes negative, that favors warmer than normal temperatures and more of the ridging across the eastern U.S. The troughing and the colder temperatures with a negative PNA stay out over the western U.S. A neutral PNA is kind of like that in between, indicates highly zonal west to east upper level winds with the jet stream and quickly moving disturbances from west to east. A positive PNA phase, now that is what you want if you want colder temperatures in the eastern U.S. You get warmer temperatures, warmer than average temperatures in the western U.S. with a positive PNA and ridging out there. Models are indicating anything from a slightly positive to slightly negative EPO through the 23rd of November. Still seeing a lot of ups and down variability in the EPO. But then one thing that I'm really starting to pick up on with these modelings, with the models here, with modeling in general, is the EPO then turns negative beyond 23 November. A positive EPO will favor upper level troughing across Alaska, the Bering Sea. Warmer temperatures across the northern plains of the East Coast with a positive EPO. A negative EPO, on the other hand, favors colder than average temps from the northern plains to the East Coast. Models are indicating a potential stratospheric warming and displacement of the polar vortex off the North Pole into Europe, right around northern Europe area by the 20th of November. This displacement could favor colder than average temperatures in portions of northern Europe. My overall assessment now, we take it all, we meld it all together. It's like mixing a salad. You got your tomatoes, you got your cucumbers. Well, we're going to mix all the teleconnections here on my final slide and kind of like what I think is going to happen over the next 7 to 10 days for the eastern United States with the main focus. The MJO progression into the western Pacific Ocean in phase 6, that's favoring milder temperatures for the east from 19 to 27 November. Especially if the Jeff's V12 is correct and the MJO stagnates into phase 6, The milder temperatures could stick around a little bit longer. A negative AO and negative NAO combination, though, through 21 November, I really believe is going to act to offset the milder MJO effects in phase 6. You see the upper level troughing, the upper air 500 millibar charts across New England. You see the troughing occasionally extend down into the coastal mid-Atlantic area. So that persistent troughing over southeast Canada and New England, association with the negative AO, negative NAO situation is not really going to budge much. And I really believe these two are destructively interfering with the MJO, milder MJO phase in phase 6. Now, the PNA, the Pacific North American pattern, looks at transition as slightly negative. We need to continue to watch how strongly negative in future forecasts the PNA becomes. A negative PNA would favor troughing over the western U.S., much stormier over the western U.S., and cooler temperatures there. But if the PNA were to become more strongly negative, we could see a deeper upper level trough over the western U.S. with rising heights and milder temperatures across the eastern U.S. Keep an eye on that. A weak La Nina is in place across the tropical Pacific Ocean there. However, the SOI has dropped dramatically over the last week. So that's something to keep an eye on. You have water temperature anomalies that kind of indicate whether you have a La Nina or not. But how is the atmosphere, the overlying atmosphere above those cooler than normal waters, how is it responding? Stratospheric warming temperatures and polar vortex displacement possible in the European side of the northern hemisphere here by 20 November could potentially result in colder temperatures on that side of the northern hemisphere. We'll see how this changes over time. And models will struggle, by the way, with the forecast. If you look at operational models, they're all over the place. One model run, it looks like it's colder in the east. The next model run, it's milder in the east. And it's because we have a potential stratospheric warming coming up. Okay. We also have this persistent negative NAO. We have a milder MJO phase. Things are battling themselves out here. The teleconnections are battling against each other. Milder influences on the Pacific side with that MJO. But then you have colder influences in the eastern U.S. from the Arctic and North Atlantic sides, those teleconnections. It looks to be a case of milder, in my opinion, Pacific influencing versus the Arctic and North Atlantic influences the next 10 days. So to kind of close it out, we're going to have a lot of variability in operational model runs, GFS, European, ICON, all of them, Canadian, all of them are going to be up and down, back and forth. Until they figure out what's really going to happen in late November with this stratospheric warming, with the polar vortex, I will say that a lot of European weeklies, a lot of longer range models are seeing a colder turn for the east in late November, early December. We'll continue to watch this, however. That is all I got for now, everybody. Hope you enjoyed my teleconnections discussion. It takes me some time to put these slides together and really analyze the data before I go ahead and present it to you. Hopefully you really enjoyed it. And that's all I got for now, everybody. Let's continue to watch things as we approach mid-November. And until next time, take care and God bless everyone.